Hello everyone. Now, should we take little more problems, more illustrations on permutations? Yes. Still to get hold on the topic, I think we need that. So, some more illustrations we'll be taking in this session. Okay. So, first illustration is the number of integers greater than 6000 that can be formed using the digits 3, 5, 6, 7 and 8 without repetition is, and some 4 options are given to me. And again, correct option is to be obtained. The question doesn't say that how many digit number, right? But condition is it is greater than 6000. So that number of numbers, what are you looking for? They would be surely 4-digit numbers or 5-digit numbers. So I think we need to take 2 different cases. Now first case could be where 4-digit numbers you are talking about. Okay. So 4 places I make and I show that units, tens, hundreds, thousands place. That thousands place can be filled by 6, 7 or 8. So 3 options are available for that thousands place. Correct? Now, also it is mentioned as without repetition. So one of those 6, 7, 8 has gone in the thousands place. Remaining are how many? Remaining again are 4 digits which are to be filled in those remaining 3 places. Correct? So total number what we are looking for would be 3 into, and see the further part what I have written, 4 into 3 into 2. Why I have written 4 into 3 into 2? Because first place has 4 options. Again, 1 digit has gone in that particular place. Then 3 options would be left for the next place. Then next to that, 2 options would be left, and so that is the explanation. So 3 into 4 into 3 into 2. That would be the number of first case. Correct? Now go from here to the next case. And next case is 5-digit numbers. Now do we have any restriction for 5-digit numbers? Every 5-digit number made up of these digits or otherwise also would be greater than surely 6000. So there is no specific condition here. So we can straight away find 5 places, 5 digits are available, and the correct count for that would be 5 factorial. So case 1's number is 3 into 4 into 3 into 2. Case 2's number is 5 factorial. So use your addition principle and that would give you 72 plus 120 and my final answer should be 192 and my correct option is B. So move from here to next one. And next one is that if all the words with or without meaning are made with 5 letters of word small, then and arrange them in dictionary order, then we have to find the place or position where the word small appears in that list. And some 4 options are given to me. Now question looks different, but of course this is also again nothing but arrangement of letters. So this comes under permutation. Now do it systematically. I mean, first don't sit and make the entire list. I'm not saying that when I say systematically, but use your approach systematically. First thing what we understand here is the letters what are used are A, L, M and S. Correct? And there would be some words which will start with A in the dictionary order, right? So numbers starting with A or beginning with A would be 4 factorial upon 2 factorial I'm saying. Why I'm saying so? First place is filled by A. Now 4 places are there and those 4 places would be filled by M, L, L and S. Now since L is repeated twice, so we are dividing there by 2 factorial. So 4 factorial upon 2 factorial is the number. So answer there is 12. Now I go for words which start with next letter which appears in dictionary order should be L. So the words starting with L we go for. And that would be straight away because 1 L you have already used. Now there is no repetition kind of thing here. So it would be straight away nothing but 4 factorial. And answer there is 24. Now I go for next type. Third in the list type would be words which start with M. And words starting with M, that first place you have fixed, again 2 L's would be there. 1 A would be there and S would be there. So 4 factorial upon 2 factorial. Keep remembering why do we divide there by 2 factorial. Okay, so answer here for this particular situation would be 12. Then I go for words starting with S, A. Why do I make that change? Because I cannot randomly take here words starting with S. Because if I say words starting with S, somewhere that small will go inside. We do not want that. So we want to now again make further, like divisions. I take words which start with S and A together, S-A. Then which letters are left? M and two L's are left. So 3 factorial upon 2 factorial. Because of repetition, I am dividing by 2 factorial. So this number is 3. And now what next? Then SL, word starting with SL. Now when I say SL, one L is already used. There is no repetition now in the remaining letters. So it is straight away 3 factorial. So answer here is 6. And then what happens? Then you know what happens? You start with SM, that kind of particular category. After SM, now A only has to occur in dictionary order. And once you fix SMA also, then only next are remaining 2 L's. So that word small comes after all these numbers. So first, let me find out total number of words which come before small. That word small. And that answer is summation, addition of all these. And that answer is 57. So before word small, 57 words have occurred. So 58th position must be the position of word small. So my correct answer is D. I hope everyone is clear with the explanation. Now let us go for the next. And the next illustration is that how many 4-digit numbers can be made from the digits 2, 3, 4, 5, 6 without repeating, and the condition is they are divisible by 4. And again 4 options are given to me. Now condition is important. They are divisible by 4. When do we have numbers divisible by 4? Can you recall that? A number is divisible by 4 if the last 2 digits of that number, that should form a number divisible by 4 actually. And the entire number would be divisible by 4. Number can be any digit number, but last 2 digits play the role. This has been taught in some previous classes only. I guess you know that. Now use this condition and understand that last 2 places now are fixed. Last 2 places I have shown their option 24, 32, 36, 52 and 56 and 64. These are the things which will appear in the last 2 places. Mind you please, I have not taken their 44. 44 also would have been divisible by 4. But then condition without repeating you are saying, so I have not written their 44. So we know now that units and tens places would be filled by these 6 options. Correct? Now we have to fill the places of 100 and thousands, right? And then 2 of the digits of 2, 3, 4, 5, 6 have already gone in the last 2 places. So how many options are left for first 2 places? 3 digits are remaining. So 3P2 should be the answer for first 2 places. Now in all how many are there? 6 plus 6. So answer should be, required answer is 6 into 6. Now not 6 plus 6. Why? We have used your multiplication principle. Be careful. Multiplication principle says that entire task, if it is divided into further subtasks, then each subtask should be complete first. Now, I have divided into 2 parts, last 2 digits and first 2 digits. Last 2 digits is one subtask. Filling first 2 digits is another subtask. And then you multiply. So 6 into 6. So the correct answer is 36. Correct? So first option seems to be the correct answer. So answer is A. Let us take next example. And that could be perhaps my last example of this session. The number of ways in which 5 beads of different colors form a necklace is, and again 4 options are given to me. This problem looks very simple, but you have to be a little careful. That is why I have taken in this particular session. Now, 5 beads of different colors, and you are saying necklace, so I expect that to be a circular thing. So normally you would have mentioned that number of necklaces would be 4 factorial, taking circular permutations. 5 beads are there, 1 we take less because of circular permutation, n minus 1 factorial if you remember, and answer would have been 24. Usually any person would have answered as 24. No. You know what? Anti-clockwise arrangement and clockwise arrangement, they are one and the same in case of a necklace. And hence, we say the required answer should be half of that. So the correct answer has to be 1 by 2 of 24. So this gives me answer as finally 12. 24 I said because of 4 factorial. That is now remembered in my mind. You can actually show the working also, 4 into 3 into 2, etc. So correct answer is 12 here, and my correct answer here in the options is D. So here I end my session. Again we meet in the next session with something new. Till then, stay tuned. Thank you. Hope you have enjoyed the session. If you have liked the video, please click on this side. And if you want to place an order for the book, click on this side. Thank you.